trigonometry in the Cartesian plane. Your homework for that is on page 413 and 414. It's just going to be problems 1 through 18. Now, trigonometry, remember we mentioned, it ends up being the study of more shapes, but it started out as the study of triangles, which is still all we're looking at. And Cartesian plane, if you guys remember from, gosh, I want to say it was one of the first 5 chapters of algebra. The Cartesian plane is just where we always do our x and y axes. So trigonometry on a Cartesian plane means we're going to be drawing triangles on these axes. So we're not really, everything we're doing is what we were doing before, except now we're going to turn it into something that we're doing on a graph, which means that you might not get a length or an angle, but you might get a point. And you might say that you're forming a reference triangle using that point. So let's talk a couple of the terms that are going to be on here. Terminal ray, and mostly I'm writing down so that I remember to tell you guys all of them. Reference triangle. What other terms are we talking about? Initial ray. We'll talk a little bit about positive angles. Let's see what else. Initial ray, terminal ray, positive angles and negative angles, and reference triangle and reference angle. There we go. Okay, so I'm going to draw all these things on here and we'll see how it makes a triangle. Initial ray is the easiest one, okay? So your initial ray is basically going to be a line. It's called a ray because it only has, it's starting from a specific point and then it's just kind of going indefinitely in one direction that is on the x-axis. So really, it's basically the x-axis. Now your terminal ray is going to be a ray that's going to some xy point on this graph. So let's say in this case it's going to, let's 4, 3, okay? Remember it's 4 on the x-axis, 1, 2, 3, 4, 3 on the y-axis. So your terminal ray starts at the origin, but goes through that. And again, it's a ray because it starts at a set point, but then it just travels in a direction. So that's our terminal ray. Reference angle, this little angle that we form here, that's your reference angle, okay? And it's measured, that brings us to positive angle. You measure the angles in a counterclockwise direction. So you start from your initial ray, and you measure counterclockwise. So think about it. Clocks normally go like that. So you're actually going to measure in this direction towards your terminal ray. And you're going to get an angle, which is your reference angle. If you're measuring in the counterclockwise direction, they're going to be positive. Now, say your terminal ray is down here, and you just want to measure like that instead of having a huge angle, then it's just going to be negative. So say that's 45, it's going to be negative 45 degrees. That's that. And then our last term is reference triangle. Well, since that's the reference angle, chances are your reference triangle comes from there. How do you make your reference triangle? You pick any point on your terminal ray and you draw a line that's perpendicular to the x-axis and hits your terminal ray. Okay, so that has to be a 90-degree angle, which means if it's perpendicular to the x-axis, it's going to be parallel to the y-axis, right? And it's just going to be a line that's x equals 2, 3, 4, 5. Let's say in this case it's x equals 6. Remember, x equals are perpendicular lines. So when you draw that line, you end up creating a right triangle, which is your reference triangle. On page 411 at the very top, it shows you a bunch of angles, okay? So the first one, well, let's do the second one first, which looks a little bit more like this. It looks kind of like this, and the angle is 28 degrees. They're measuring from here to here. Now, if you look at the one to the left of that, your angle's actually over here, and then you form your triangle right there. Now, the angle goes like that, so it's going to be 90 degrees plus something, right? It's going to be really big. In that case, it's 139 degrees. Okay? And then there's one that's 300 degrees, which comes down here, but then they do another one, which is kind of here, and they measure it from here. And it says that it's 120 degrees, but because we're measuring clockwise, it's negative 120. Now, why does that all matter? It doesn't really, except in a little while when we use sine and cosine values, you're going to see how some of these angles mirror each other in the values, okay? But that's just kind of illustrating that you're always measuring from your initial ray. If you measure counterclockwise, it's positive. If you measure clockwise, it's negative, okay? All right, we already talked about how we form the reference triangle. And then how are we gonna find values for these reference triangles, right? We've learned how to do sine, cosine, and tangent. Oops, I was gonna write tangent, sorry. Okay, now we can still do those here, except now we can put those values in terms of x and y because we're drawing it on a plane. And for some of these problems, they might give you a graph, and they might say, draw the reference triangle that goes through point, what do we do here, 4, 3 or something like that, so they might just give you a point. Or they might say, what's the sine of the angle, whose terminal ray crosses this point? And you actually won't even have to draw the triangle to figure out some of those, okay? Because sine is opposite over adjacent, right? I mean over hypotenuse. Remember SOHCAHTOA. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay? Now, a lot of these you can just do in terms of x and y. What is our, remember this is our reference angle. Okay? So that's hypotenuse. We're just gonna call it, I think they call it R. Yes. Because of the ray. But then for sine, what's our opposite? It's right here, right? What's the length of that? It's just whatever your y value is because it's starting at y equals 0 and it's going up to, in this case, y equals 4. So you can just say y over r. Cosine is adjacent, which is basically your initial ray, over hypotenuse. So we know it's going to be over r. Now what's the length of this adjacent? It's whatever your x value was in the point. So it was 1, 2, 3, 4, 5, 6, because that's where we drew our line. Depends on where you draw your line. In that case, it's going to be 6, so it's x. Tangent is just opposite, which we already said was y, over adjacent. So sometimes you won't even have to draw the triangle. If you know the point, and if you know where you drew the perpendicular to make the triangle, you might not even have to draw it. You might just be able to figure out these values. So it's just a little shortcut. Let's see what else we have to do. On page 412, it says that angles with the same terminal ray have the same ratio. So what does that mean? I'm going to kind of redraw that, except hopefully a little bit less busy. I'm not going to draw the little markers, okay? I'm just going to draw this angle, okay? So what's an angle that has the same terminal ray? Well, you're basically following this line. Okay, so there's this angle, let's call it reference 1, that's formed by that terminal ray, but there's also that angle that's formed by the terminal ray. And what does it mean by, if you look at the end of the first sentence on page 12, angles with the same terminal ray have the same ratio. That means that they have the same sine, the same cosine, the same the same tangent, okay? So technically you can't make a right triangle with this angle, right? Because the angles in a triangle add up to 180, and this is bigger than 180. Even though you can't make a right triangle, you can find the sine or the cosine or the tangent for that value because you know that it's the same as that one. So what is this angle? Let's say that one's 50, right? So that means this is 90 plus 90, which is 180, plus whatever's left there, which is 40. So it's 180 plus 40, which equals 220. 220 and 50 are going to have the same sine, the same cosine, all of that. In this case, they're doing negative 340 is the same as 20. So that's, well, their angle's a little bit different. No, it's close. So they're saying that this is 20 degrees if you look at it from here. Right? In this case, let's say it's 40 degrees if you look at it from here, but if you look at it this way, it's a different value. So same in this case, this is 50 degrees, sorry, we decided this was 220 degrees, but if you measured it this way, it's 50 plus 90, 140, negative 140 degrees. They're gonna have the same sign and the same cosine. Why does that matter? I guess because if you already looked it up once, you don't have to look it up again, but it's just something that's cool to know. And there's a whole proof that goes through why that's the case, but we don't do proofs, so we're not gonna go through that. It just means that depending on what terminal axis they give you and what reference triangle they give you, you might actually have, this angle, or you might have the angle that goes in the opposite direction, but you can calculate them, or you can calculate the sines and the cosines for one, and you can have the value for the other one. So let's look at the second picture there that has a circle. Okay, let's erase this busy one. And the only reason we're bringing in that circle is because we're going to introduce radians. It's just a different measure of angles. The tables that were in the back of the book that give you sine and cosine and all that, they give it to you for certain angles, which are measured in degrees, but then they also give it to you for angles measured in radians. It's like measuring temperature in centigrade or Fahrenheit. It's just two different units of measurements. And the radians, if you think about it, sounds a little bit like the word radius. So it actually came from circles because you're drawing triangles and your hypotenuse is actually the radius of a circle. Okay, so again, we're looking at page 412. And we're going to draw another triangle. And we're going to say that your terminal ray is going from the origin to a certain point. And that, so we can draw a reference triangle, right? Right there. But you know what else we can do? We can pretend that we have a compass, and we can draw a circle that has that radius. So pretend you have a compass, and you just turn it all the way around. I'm not going to do a great job at this. But you draw a circle whose radius is the same length as whatever your hypotenuse of this reference triangle is. Okay? And that'll also, you can use it to help prove the fact that the cosines are the same if you have the same terminal radius, but you can also use it for some calculations, okay? So, if you have this, the easiest way to do it is to set the radius equal to 1, which means that this is equal to 1. So then that's going to be your y value, and that's going to be your x value, right? So you can set a radius equal to 1. You can look in the back at all the calculations for sines and cosines. But you know that, for example, sine is opposite over adjacent. So if your radius is 1, it's going to be y over 1, which is just y, right? Your cosine is going to be x over 1, which is just x. So if you have your terminal ray, if you cut it off, so if you draw your reference triangle so that r equals 1, or so that your terminal ray equals 1, it makes your calculations for sines and cosines a lot easier, right? It's just going to be x or y, because anything divided by 1 is just 1. Well, what does that mean? Really, if you want to extrapolate it, if you have exact numbers, so say you draw this where your terminal ray is of length 2, what's your sine going to be? Y over 2. Cosine is going to be x over 2. So you can take that a little bit further if you wanted to, but 1 is the easiest number to do it with. Now, what does that tell us? Hold on. So, if your angle is right here, right? If your angle is 0, that means that this line is right here. So that means that x is also equal to 1, right? So that tells you that the sine of 0 is 1. And again, this is kind of proof-like stuff, so you don't really have to memorize this logic, but it's just telling you how they get to those numbers. And if you don't remember that the sine of 0 is 1, it doesn't matter because you can plug it into your calculator. But this is how we get to that point. If your angle is 0, then really your terminal ray is going to be right there. So it's going to be equal to x, which means that you're going to have a sine of 0, of your angle 0 is going to be equal to 1. What are other possibilities? Okay, if y equals 0, this is also going to be 1. Your cosine is also going to be 1. cosine of 0 equals 1. And then what's our last thing actually? Our tangent is also going to be 1. Okay, so for value of 0, all of your ratios are equal to 1. And actually that's all it says. So just remember, if you have an angle of 0, all of your values are going to be 1. And if you think about it, your secant, your cosecant, and your cotangent are also going to be 1 because they're going to be your reciprocal. What's the reciprocal of 1? Also just 1, because you're doing 1 over the number. Okay, so these are just, this section was a lot of proving why numbers are such. Terms you have to remember. You want to remember your terminal ray, initial ray, reference angle, reference triangle. And then just know that when they give you problems on a Cartesian plane, sometimes you're going to get points in the term of x in the form of x, y, and you're going to have to use that to draw your triangle. Instead of getting a triangle with some missing angles or stuff like that, you're going to get a point and you're going to derive your triangle from that. So let's look at a couple of examples. I'm going to try drawing Cartesian planes, which we know doesn't go very well on the board. But the first problem says find the secant of 230. And remember, the secant is just 1 over the cosine. Okay, so it's the inverse of the cosine. I always remember secant goes with cosine and cosecant goes with sine. That way each of your pairs has a co. But all right, and it's of 230. Now they're giving you a positive value, right? So you got to go 90, 180, 230 is going to be somewhere past the middle here. So this is your 230 degree angle, and they want the secant. Now, if you go to the back of the book, say you forgot your calculator, and you go to those pages that have the tables, you will notice that those tables don't make it all the way to 230. The highest value that they have is 90 degrees. So how, if you don't have your calculator and that table only goes to 90, are you going to give me the secant of 230? You're going to remember what Dr. Teague just told you, which was that if you have the same terminal ray, you have the same ratios. So that's positive, but remember you can count clockwise and just make it negative. Well, the really easy way to do this is, it's a circle. Circle always adds up to 360. So this angle is actually going to be 360 minus 230. So it's 360 minus 230, which is what? 130? Check the math on the book. They're not asking me to find the, oh, they are asking me to find the cosecant. Okay, sorry. So this is going to be 130. That also doesn't have a value in the back because they only go up to 90. So that's going to be negative 130. So how else can we have the same terminal ray? What if we just continue this guy up? Look at that. Then we happen to have a positive angle here that's 50. How do I know it's 50? Let me tell you. This is 230. It's 90 from here and 90 from here. That's 180. And then I got this by doing another 50. So I know that that little angle is 50. Well, I know that this square is 90. So that little one must be 40. Okay? So this one and that one are going to be the same. This one and that one are going to be the same. There's a whole set of proofs for that, but we're not going to go over it. You just know that since you had to add 50 to this guy, that's what you're going to add there. 50 is a positive angle. I think I can probably go to the back of the book and figure out what the 50 degree angle looks like. Let's see. 50 is on page 616 on the right hand side, right about the middle, and I want the cosecant, and it says that the cosecant is 1.305, I believe. Hold on. Oh, it says secant. I'm sorry, I looked at cosecant. Secant of 50 degrees is 1.556. Now, you just have to remember that if you're doing it in this direction, right? It was 230 in this direction, which means if you were counting from here basically, well, sorry, if you're counting from here, if you're counting in the opposite direction, if you're counting clockwise, it's negative, and so all you have to do is say that it's negative, so it's just the negative value. Okay, so if you cannot find your secant, your cosecant, your tangent, your cotangent, basically if you have an angle that's over 90 degrees, you can do two things. Depending on where it falls, you can count it counterclockwise in this direction, or you can just use your same terminal ray, continue it up to a quadrant where it's going to be less than 90 degrees, and then you'll be able to find your value. Depending on how you do it, you're going to have to flip the sign, or you're not going to have to flip the sign. Okay? In this way, we counted 230 degrees counterclockwise direction, which means it was a positive angle, but it didn't have a reference. It didn't have a value in the back. So how do we do it? We get this value, but we have to count it. It's the same as this angle. We have to count it in the negative direction. You're counting from the ray up. You're counting clockwise direction. So it's negative 50 degrees, which all that means is you switch it to negative, right? So if you're counting positive direction, if you're counting counterclockwise, it's positive. Counting clockwise, it's negative. You have to have an angle less than 90 so that you can reference it in the back. And honestly, I don't have a scientific calculator, so I don't know if you can just plug in secant of 230 on your calculator. If you can, well then you really don't have to know any of this, do you? But just in case you forget your calculator, that's how you do it. Example 2, find the sine, cosine, and tangent of a 180 degree angle. Okay, well that one's gonna be really easy to draw because it's just a straight line, right? That's 90, that's 180. So there's my terminal ray. What other information do they give me? Draw the angle, we did that. The terminal ray is on the negative axis. Choose any point on the terminal ray, and then we figure out the values, okay? So let's mark 1, 2, 3, 4, 5, 6, 7, 8. In the book they do 4, so we're just gonna stay with 4. Remember, that's negative 4, but it's a distance, so we're just going to use 4 as our distance, okay? So, what do we need to find as our values? What's our x? What's our y? What's our r? Why are we finding r? Because remember that if you have r, you can do your sine in terms of r and your cosine in terms of r, and your tangent in terms of x and y. So your sine was, I'm just going to look it up because I forgot, y over r. Your cosine was x over r, and your tangent was x over y. So they want to know sine, cosine, tangent, that's it, of the 180 degree angle. So our value for r is 4, and x and y, and our value for x we can figure out is also 4. What's our value for y? It's 0, right? Tangent is tangent is y over x. That's what I thought, because this was going to be undefined. So we can figure out these values. In this case, we don't even have to go into the back of the book. Now, if we did have to go into the back of the book and we had to find an angle, our only choice for angles is going to be 0, which I think is in the back of the book. Yeah. 0 is one of the angles in the back of the book. Why is our only choice 0? Well, because it's on the straight line, right? So what's our choice? We could try to count it counterclockwise. It's still going to be 180. Or we could use this terminal ray. We could use this as our starting point. We could use that as our quadrant, in which case you'd measure counterclockwise from this line. Remember, it's on the line, so it's 0 degrees. 0 can be positive or negative. It's the same value, 0, okay? But let's do it using the formulas that they gave us for when you draw something on a Cartesian plane. Because they're telling you to just pick a length. They're telling you to pick -4, 0. What's sine? What's our y value? 0? Doesn't matter what r is, right? Your sine is going to be 0. What about your cosine? It's x over r. X and r are the same. Again, it doesn't matter what point you pick. We could have picked 7 as our point. It would have still been 7 over 7, which would have still made this 1. What about our last value? Is y over x? Y is 0. Doesn't matter what x is. Tangent is going to be 0. So that means for 180 degrees, also for 360, your sine is going to be 0, your cosine is going to be 1, and your tangent is going to be 0. Sorry, it's going to be -1. Because your x value is -4, sorry. Right, because x is -4, r is just a length, so it's always +4. But let's pick a different number just for kicks. Let's say we picked the number, we decided to do it right here. 1, 2, 3, 4, 5, 6, 7, 8. So x is actually -8, and r is actually 8. What are our values? Y over r, again, is 0. X over r, again, is -1, because x and r are always going to be a positive and a negative version of each other for a 180 degree angle. And what's tangent? Again, it's 0 because y is 0, so it doesn't matter. So for a 180 degree angle, those are going to be your values, 0, -1, and 0. It doesn't matter what you choose as your point that you're going to use for your reference triangle. Okay, so you have those two ways to calculate stuff. In problems 1 through 6, you have an angle. So it tells you to draw the reference triangle and give the measure. You can just, if you want, draw one set of planes, like one set of x, y coordinates, and you can draw all your angles on there. Now remember, for problems, let's see, 2, 3, 4, actually everything other than 1, all of those angles are bigger than 90 degrees. Oh, sorry, they just want you to draw the reference triangle and give the measure of the reference angle. So you need an angle that's less than 90 degrees. So go ahead and draw your angle at 345 or at -140. But remember to find the opposite angle. The angle if you count counterclockwise instead of clockwise, or clockwise instead of counterclockwise. Remember that you have to find a way to find an angle that's less than 90 degrees. Okay, so it can be positive or negative, but the actual number has to be less than 90 degrees. For all of those, you're going to do something different. In problems 7 through, 12, you're going to find the sine, cosine, and tangent of the angle. Now, for all of those, it actually gives you points on the Cartesian plane. And actually, you guys don't have to do problem 12 if you don't want to. We can do it as an extra credit. Okay, so 12 is extra credit. Okay, so for those problems, you're not going to do it like this. You're actually going to do it like this. So you're going to use sine is y over r, cosine is x over r, tangent is y over x, and you're going to find them. You don't even have to draw it in that case, right? You just have to put in the numbers. Now remember, you're going to have to figure out what your r value is, right? So you're going to have to do your a squared plus b squared equals c squared. You can just plug in x squared plus y squared equals r squared. So you can find that, again, without drawing the triangle. So in the first problem, you have -2 and 1. Remember, you're going to square them, so it doesn't matter. So it's 2 squared plus 1 squared, which is what? 2 squared is 4, 1 squared is 1. So it's r squared equals 5, r equals square root of 5. So you have all the numbers, okay? So for 7, 8, 9, 10, 11, use this formula to figure out r, and then use these formulas to figure out all your answers. There will be no drawing of triangles for those. And then for 13 and 14, you have to use it says do not use a calculator or a trigonometric table. Both of those, when you draw them on the Cartesian plane, you'll see why they're telling you that, okay? So you have to say what's the sine, what's the cosine, what's the tangent. And in exercise B, problems 15 through 18, you're going to find the ratios by using the reference angle. What does that mean? For actually all of those, except number 16. Your angles are all bigger than 90, so you have to do this. You have to either count in the opposite direction, find the other angle that's formed by the same terminal ray, just kind of draw your lines and figure out what your options are for that one, okay? That is all of this section, and I'm sorry it's so complicated. We will have a Zoom tomorrow where we can talk, actually, By the time you guys see this, we'll have a Zoom today, and you can ask questions, and if not, remember, you